As many of you have probably experienced, writing a report can be a pain. It can be time-consuming, tedious, and may offer no short-term benefit. On the other hand, they are an important source of knowledge for later and can be used to track system and human health. In the healthcare industry, this challenge has been tackled by voice user interfaces called digital scribes that are used to report what has been done and what has been observed. They've been shown to improve accuracy and productivity of documentation. For this study, we looked to industrial maintenance as a case study. This is characterized by one-on-one training, which is resource intensive, but also novices and others that use existing reports to see what they could do. However, these reports are often poor quality, which means they're not so usable by humans or by machine learning for knowledge discovery. The AI assistants in this industry do already provide information retrieval and task support based on static knowledge bases. So our hypothesis is that by using a voice user interface and a think out loud technique, we can go beyond simply reporting what has been done, but also how and why it has been done in this way to efficiently create rich reports for continuously learning humans and AI. To test this, we developed a user study in which participants were asked to replace an inner tube of a bicycle and create a maintenance report. One group performed the maintenance task and then wrote the report on paper afterwards, the status quo, whereas the second group used a simulated voice interface to report what they were doing, why they were doing so during the maintenance task. We have three main measures: perceived workload, time, and report quality. Report quality here is defined as the frequency of information that can help the reader understand what, how, or why the task was performed in that way. The voice user interface followed a few simple rules. It uttered a continuer or interjection at the end of a user statement or subtask completion, like OK. It clarified pronouns when it was not directly obvious from the context. And lastly, asked for a checkup if the participant had been silent for a set period of time. If we look at the results of the report quality, so here we coded 4 types of information: procedural, referential, task state, and internal state, all of which were in favor of the CUI condition. Most notably, internal state, which is the valuable explanations that users provide. If we look at the task time, time to complete the entire task, so maintain the bike and write the report, it was much faster to do so with the CUI condition, and the time just to change the inner tube was the same across conditions. In summary, using a voice user interface resulted in reports of higher quality, which can be attributed to the efficiency of being able to speak. The fact that think out loud naturally resulted in explanations and further details, with the caveat that as we were simulating the voice user interface with a human, we could minimize the effect of the interface quality on the results at the cost of realism. Secondly, that using a conversational user interface saves reporting time, yet does not affect the time to complete the primary task, which could be attributed to the fact that thinking out loud is natural and does not impose a high cognitive load on the user. The fact that they were multitasking and could report while they're performing the task, again with the caveat that if we were to generate an actual report from the voice user interface, they may need to proofread this, which would add time. Finally, we saw there was equivalent total workload between conditions, only temporal demand was perceived as higher for the CUI condition, which could be attributed to the fact that they were multitasking and sometimes asked for updates. Future work could explore how to improve the user experience and knowledge acquisition of the interface, and in turn how this information could be used to provide recommendations during task execution or later. Finally, future work could develop a prototype to improve the realism of these studies. Many of these points are being tackled by myself and colleagues of the Koala Consortium H2020 project, in which we aim to develop a cognitive assistant for providing on-the-job training and knowledge sharing for factory workers.